All right, so we're gonna talk about the integrals of certain things. So we already know what is sine of u du. Do you guys know what's integration of sine of u du? Huh?
Hmm?
What's integration of sine u du?
Negative cosine.
Negative cosine of u plus c. Yeah.
Yeah.
Okay, so yes, I can see what you're saying. You probably think about that's gonna be positive, but because derivative of sine is positive cosine of x, but derivative of cosine of x is gonna be negative sine of x, therefore you get negative. And what's integration of cosine of u? It'd be sine of u plus c, right? So this is very easy, and you say, oh yeah, you get this. Sorry. Then what we're gonna do is there is some integral that we don't know about. For example, what is integration of tangent of u? Right, question mark. And integration of secant of u, right? Then question mark, right? Question mark. And also because of this, you got integration of cotangent of u du. And what is cosecant of u du here? Okay, so this all question mark. We don't know about. But we also know something else from before. Like we actually know what's integration of, let's say, secant square of u du. What's the integration of secant square of u du? 10 of u. Good. Right. And there's a question about cosecant square of u du. This one we also know as well. What is that? Negative. Okay. Yeah, and then there's one more, which is the sexy 10. U 10u du is what? Secant of u plus c. So integration of the sc of u and cot of u is equal to negative cosecant of u plus c. So the only thing is the two things that we're missing. Because if we figure out a two thing, the other side is going to be a complement. So if you realize, like, see, integration sine of u is negative cosine of u, and cosine of u is sine of u, they follow the same pattern. Or integration of secant square of u du is equal to 10 of u, then integration cosecant of u du is going to be cotangent of u, negative plus c. So they follow the same pattern. So only things that we need to find is those two things right here. Okay. So then let's go find those two things and come back to write that, okay? So what is integration of tangent of x plus c dx? Oh, by the way, I just want to put a reminder. A lot of people like say integration sine of 2x dx like this, and they just think about that's cosine of negative cosine of 2x. It's not. Why not? Huh?
Integrate, it doesn't work. When you divide them.
You divide, it doesn't work, right? So a lot of misconception that's going to be cosine 2x, this one's negative plus c, and that's not the right answer because this is what you do on a test. What you supposed to do is u equal to 2x, du equal to 2 dx, and a du over 2, so it's actually 1/2 of cosine of 2x plus c negative. It's actually 1/2. Now, if you do it really quick in the future, there's a quick way to think about this. When you see this 2x, it's just going to be 1/2 in the front. Okay, so that is an easier way to think about it. So if you integrate the sine of ax dx, so that's going to be 1 over a in the front. Okay, does that make sense? Yeah. Because that's a faster way to think about it, but please do know how to do u substitution. That's where they come from. But if you can do it fast, you can think that way. Okay. Now what's the integration tangent of u? Any question about any way how do I integrate 10 of u?
A you should represent.
It's something you know how to do. Already know how to do.
I could maybe the trig identities.
Okay, what kind of trig identity will help you in here?
You could do sine x.
Sine over cosine. Okay, sine of x over cosine of x dx. Okay, what is u equal to in this case? U equal to cosine of x. Always on the bottom. Why? Du equal to negative sine of x dx, right? And if you see that du over negative sine of x dx, you see that sine of x would cancel out. So your goal is to cancel out that out. So du over negative sine of x and sine of x cancel out. So be negative natural log of cosine of u plus c, or cosine of x. Yeah, cosine of, no, natural log cosine of x, my bad. So we figure out one of them, which is nice. Which is something you know how to do already. I don't need to teach you. Deborah, what's your question?
Wait, so that's the integral.
Yeah, that's integral of this, so it's equal to negative natural log cosine of u plus c. So what do you think integration of cotangent of u using the same pattern? What do you think the answer will be? Sine of u plus c. Good. There's no negative this time because u equal to sine of x on the bottom, because the cosine over sine. So when you take a delta, it's positive. So therefore, it's not changing. Right? Now, comes to the one that most difficult to memorize. All these are very easy to memorize, and all you guys should know. Now, integration of secant u does it happen often? I would say in AB it doesn't happen often, but I will test you. Okay. So my tests are different in AP exam. So I will test you integration of secant of u, even though AP exam doesn't really test it very often because they know students don't know how to do trig. And I just tutored a girl from Windermere High School yesterday. She says none of the students over there know any trig value. So if you ask them sine of pi before, she will have no clue, or he will have no clue. So on Windermere High School, they were so far behind, they were a chapter behind, and they don't know anything, and that's normal. So that's why AP exam, guys, that's why AP exam doesn't really test you trig that much. They understand kids doesn't have the trig skills. But for me, I want you to get a 5. I don't want you to get a 4 or 3. So I want you to all understand all the trig skill. So therefore, this one is a harder one to remember. So this one is going to be secant of u du. Okay. Sorry, I'm going to x. We're going to start with x here. So what is secant of x dx? Now, like I said, mathematician, if you're the greatest mathematician, they have the most creativity. A lot of people think math there's no creativity. A lot of people just math is long division. It just follow the steps. But the problem with true math is not follow the steps. They are actually very creative, and it can be demonstrated on this question. I'm going to show you it can be demonstrated on this question. So integration of secant of x, right? And I'm going to say you have the right tool to integrate this, but you just cannot see that tool. So what people come up with this, that just show you how genius mathematician is. They are the most creative individuals more than any other subject. So how do I do integration of secant of x? They do reciprocal? No. Any ideas? No, 1 over cosine doesn't help you because u equal to cosine of x du you don't have a sine of x. So let's come up with a way that to integrate this, right? So I'm gonna show you the truly genius. I don't if you play in chess, you know what I'm talking about. You can see the mate in 12 or mate in 10, which is you can see the checkmate 10 move later, and then you can do this. Okay, pay attention. So what you can do, that's what mathematicians do. So what did the mathematician come up with this? So secant of x, and they decide multiply this by a certain things, and they multiply this by secant of x plus 10 of x. And you're like, why? Not only that, if you multiply secant of x plus 10 of x, you actually change this fraction. So what to avoid that is we're going to secant of x plus 10 of x. So is this 1? Okay, so can I multiply by 1? Yes, I can. Okay, so dx. And this was the way to solve the problem. And you're like, why do they make this problem look harder than before? Do you guys see it? There's endgame to this. It's beautiful.
Well, the integral.
Shall I show you one more step?
No.
But you still have the denominator. But you can pull that out, right?
Oh, is it because when you integrate secant x plus tan x, you get the top?
Almost. I think you said the wrong word.
Derive, my bad. Derive.
There we go. So what Devin says, it says, what happened if I distribute this, right? Secant square of x plus secant of x, 10 of x. Like, and this is going to be secant of x plus 10 of x and dx. And it's like, why this problem look harder, but it's not harder. Pay attention. What Devin says, if I said u equal to secant of x plus 10 of x, what is du?
Sexitan plus x.
Secant x 10 of x plus what?
Secant squared x.
Does that look awful familiar?
How convenient.
It looks like exactly on the top. It's just in a different order. But since it's adding, it doesn't care. Do you see that? So can I replace all those with du? And then du over u. Voila. Or you can cancel the secant square, secant 10 of u if you solve for dx. I just didn't want to write all that out. Then you got du over u. Right? Natural log of secant of x plus 10 of x. And then plus c. It's that elegant solutions.
It's the same thing for cosecant.
It's same thing for cosecant. Exactly right. But you gotta think about it. How does a mathematician come up with this? They have to see it so far ahead. They have to think about all the possibility that can be happening. It's kind of like, I don't know, what's that guy in the Marvel, the time travel guy, the time Doctor Strange? Yeah, you can see all the possibility and you see which one lead to the right result.
But when in the middle of a test, it's right.
And so in the middle test, you want to memorize this, unfortunately. It's equal to natural log of secant of x plus 10 of x plus c. And this one is going to be negative natural log, same pattern, CSC of x plus COT of x plus c. Now we just fill in all the trig integral that we can think of. Now, this story might not be appropriate, but I don't really care.
I love it.
So you don't want to listen if you're too immature. Just not immature, too mature. Then just close your ear. But anyway, one time, like I was teaching. So I was teaching a very ratchet class, right? And this ratchet class was well, they were in calculus, and there were a bunch of ratchet students. And there was a student named Manuel. And sorry, he's really funny. He's from I think he's from Peru. He's from Peru. And then he was like, huh?
No.
He was from Peru, and he was like, so I was going through this problem, right? We were talking about sexy 10 before we were talking about this, and he was like, my God, that's so impressive, Mr. A. I think I just got turned on by this problem. That's what he said in class. Anyway, every class was like silent, and I bust out laughing. I was like, if you got turned on by a math problem, it's great.
Yeah, I'll look at there.
But anyway, that was a funny part.
Wow,
I thought it was funny. No, but you should have been there. You would have. It was like it was hysterical. Like all the people were laughing. But you gotta understand this kid's personality too. This kid just like a very, like genuine. There's like he doesn't try to be funny, but he's a funny person. But yeah, basically he was. But anyway, so that is the integration of secant x. No, I mean just thought it was funny. I was laughing. I don't really care. You guys say way more inappropriate thing than I do. I don't know. Do you?
Do you?
Okay. We're losing our mind.
Isn't that just equal to secant?
Good. Can you figure out how to do it? So this is the first question, and this is the second question. Second question is a bit harder. I would say find average value.
Hold on, brother.
Hold on.
Hold on. I know just finish writing. I'll let you think.
Yeah, that's honestly kind of.
Oh no.
I like this one.
You just wait.
Okay. Much time I have. One plus tangent square is what? What is one plus tangent of x? Good job. It's secant. It's trig identity.
Oh, because the radical on both that 1 plus 10 squared equals secant squared, but since there's a radical,
Okay.
yeah.
What is that pi over what?
So that's integration of pi over 4 to 0 to the secant of x. Does that make sense?
Yeah.
And that becomes something we know, even something we don't know before, going back to the basics. Okay, so going back to the basics and go and see things, let's just say integration between 0 to pi over 4 secant x dx. Now, some people says, do I have plus c here? No, there's a definite integral. So what's integration of secant of x?
ln of absolute values.
There we go.
Doesn't really matter.
Don't have plus c because you don't have plus c because you have boundaries.
Yeah.
So don't plus c because c and c is one of them has c, the other one has c. They cancel out. Yeah, they subtract each other out. So now, so all I gotta do is plug in the hard part. So secant of pi over 4 plus 10 of pi over 4 minus natural log of secant of 0 plus 10 of 0. And then what's the secant of pi over 4? What's secant of pi over 4?
Radical.
Yeah.
What is secant pi over 4?
Radical.
But
What is it?
Radical.
Radical 2 is good, I think. plus 1, and then minus natural log of 1 plus 0. So it'll be natural log of absolute value square root 2 plus 1.
I wasn't jumping. I didn't need it to do it. Like, I'm like, it was just a
So what's going
password.
on?
I like your password.
Yes.
I would give it a pass.
Thank you. But no, seriously, I wasn't trying to be mean. or anything.
I know.
Deborah.
You know, like when I get loud, people like. I mean, I do why, but like, yeah, people get.
Is the problem still going?
He is.
Oh, we're done.
It's
Oh, that's it.
It's also never really that serious. Like, when am I ever gonna get you mad at you for a natural walk?
I don't know, maybe if I.
Okay, so what's the integration of tangent of x? Tangent of x? Oh, by the way, I forgot something.
Negative natural walk.
I forgot a pi by 4 in the front because of average value, right?
Huh?
Huh?
Because I want to find the average value of this.
Yeah.
So I did forget a pi by 4. Don't forget that. Now, you guys should not get confused between average value and average rate of change. What's the difference? Average value is integration. Average rate of change is defining the slope, which is fb minus fa over b minus a. So in this case, it's average value. So you do 1 over b minus a in the front, integral that. So therefore, it's natural log with what? I think it's cosine of x.
Yeah, it is.
And I'm going to change the pi by 4 to 4 over pi
But it's
negative. Yeah, negative. I'm going to put a negative in front. So pi by 4 and 0. So negative 4 over pi. Natural log cosine of pi by 4 minus natural log cosine of 0. And that's because equal to natural log of square root 2 over 2 minus natural log of 1, which is 0. So it'd be negative 4 over pi natural log square root 2 over 2. And that's it. And this actually come out a very nice answer.
That's nice.
Huh? Yeah, of course. And there you go. There's all the trig integrations. And you guys are so much smarter than before. Is that okay?
Yep.
Edison's kind of quiet today.
I know.
What happened to you?
Do you have the homework already, Miss Ian?
No, I don't have homework. already.
No.
Never done it.
He had it yesterday.
That's why. And it wasn't what he wanted.
What'd you say?
Nothing.
It's real fast now.
Oh my God.
Okay, so you guys are almost there. We got probably half about 2 chapters to go. We should finish before spring break.
With all calc?
Yeah. And then we should review rest of the way, and then we'll have. I want to make sure everyone got a 5. Now, if you're a junior, you got a 5, then automatic change to an A.
Seniors.
Senior, they have to do it on mock exam. So your mock exam, you can take as early as after March, and then I will change everything to an A.
Do, but like I want to make sure my third and fourth quarter looks like because that's when AP reviews my credits.
Yeah, we have another time, and also I'm gonna open up Saturdays. Saturday is Saturday you can do mock exam. Oh, mock exam only on Saturdays, and you can take as many as you want. So you can take more than once. You can take it twice or 3 times if
I'll
you
take it
want to.
every time, not mostly.
Yeah.
So I get, or if even if I get, I would probably keep taking it just to like keep getting caught.
Yeah, so so for me that I will make sure, but your spring break is gonna have a lot of multiple choice homework, a lot. You are gonna have probably a lot.
Are we gonna have a test right at the end of spring break like we had a winter break?
End of spring break?
Like the day before the winter break?
No, I'm gonna be gone. I'm going to different country. I'm flying.
You're gone.
I told my wife I'm gonna take him to France, so I'm taking him to France. I'm taking the kids and everybody to France.
Yeah, croissant and everything.
I don't know how to speak French, so I'm screwed.
Well, I can't feel bad.
Huh?
You don't speak French.
Yeah. And I heard they don't like people speak English over there. Yeah, they hate people speak English though.
You don't speak English, man.
Yeah. I need to ask Paige how to speak French. My stomach hurts. It's a homework hard. Homework's easy.
Not very easy. Or was very easy.
What are you doing?
I don't know. I'm waiting for everyone else.
I just want to go over there and pull the chair.
Ah!
That'd be really funny.
He did it for you. Ow, that hurt.
My stomach hurts.
Why not me, you know? Miss you. Like, it's...
No, no, you can't.
Just pull the chair out. Pull that chair.
Oh, Jesus Christ. Ah!
You're gonna hyperextend his knee. That won't be
you
fun.
know, I'm trying to make him double his power, you know. He
No,
can
no,
bend
no.
one way, he has to bend the other way.
You're broken on your chest.
No, no, you wanna keep doing that? That's what I thought.
Oh, say, wait. It's like a funeral song.
Lord,
To say goodbye.
What?
Right,
I don't know what's
I
happening.
don't know where.
peace.
I'll need you. I'll be your beast.
Sorry to do that for me. She's like, okay.
One's flat. No.
Okay, punch it, Richard.
Like, the black one has like 2 widgets here that you can do this, but this one has 1 that you can do this.
That's a different.
Funny.
I need a big fork. It's pretty long.
Yeah, no, but no, like I'm talking
I
about like the
alternating tests is pretty easy.
Like, yeah.
I don't know. Yeah.
But like it's kind of way down here. Not down
That is not my height. Oh, you mean that's, oh, that's.
We're going to touching him.
That's weird.
We need to make him so much taller than you. Wait, what? I am literally. We need to black. What is?
Yeah!
Oh, did you? All right. What do you need a tall person for?
You can't lean on it.
Get on your back. Okay.
Oh my god, dude. Whoa.
I didn't get
Oh,
money back to
taller
work.
than me.
Put me down. Put me down. Put me down. No.
Come on.
I didn't expect this to work.
Boys' maturity levels. No, we matured back. Did you expect me to just face plant in the whiteboard? What did you want from that? What? What did you expect?
I didn't think you were gonna do it.
From
Say probably can't. 5, 5, 6.
They're not even that heavy hard.
Hey!
I don't.
Not there, get off.
Harmon's trying to carry back right up.
No, I
Get off.
Wait, no.
What's going on here?
Well, you know, I was talking to Tycho and the other.
I always knew you were on bottom. Harmon, what's with you? Why
Yeah, I'll be at class. Come on, come on.
Literally not. Just don't get out of my back. No, you can't. What did it look like? Hey, yeah, wait, what? No. That's good. That's fair. Wait, Darby, I can do this here, okay?
Yeah, and then put your hand on top. Yeah, and then
If you want to knock them out, you have to take the blood.
Let me be clear. Let me be clear. I'm Mr. Ye. It's me, Mr. Ye. That, oh, come on. You can't do that.
Did you guys see the sun? Yeah.
Yeah, we're not creative and probably trying to get the show. I mean, come on, Tomorrow, Marty.
Yeah. I'm not a figure. Dude, 7 questions. It's so deviated.
This isn't even
I did no.
I did at least. See?
What?
It's pretty easy. My gosh.
There we go.
All right. Shh. All right, homework. You guys okay? Should I give you odd answers? I don't have even answer. I have odd answers here. That's all the textbook is. The textbook always odd. Okay, but at least I'll give you odd first then. All right. Shh. The odd answer from we start from 5, right?
Yep.
Okay, 5's converge, 7's converge, 9's diverge, 11's diverge, 13's converge, 15's diverge, 17's diverge, 19 is converge.
What about the even?
I don't have even. 21 is converge, and don't worry about 23. But 23 is converge in case you. Okay, so what's question 6? Is that converge or diverge?
6 is double.
It's diverge because limit x approach to infinity is going to be 1/3. So it's diverge, it's not equal to 0. And what's number 8? Huh? Converge y. Why is number 8 converge? Okay, shh. Number 8 is converge or diverge? Converge, okay. Number 10. Shh. Why is it diverge? Actually, this one I'm not entirely sure, but I think it's decreasing after 3 though.
It's decreasing after radical 5.
After radical 5, which is roughly 3. Yeah, closer to 2. So 2 point something. So I looked up online. This one that's actually converge. I guess at very beginning stage is fine, but I'll double check reason why. But I'm not entirely sure. But if I check Simple Lab with Xavier yesterday, and we say this one's converge. But I'll double make sure reason why, because not entirely sure. 12 it's converge or diverge? Shh. Huh? Converge? Okay. Shh. 14? 14 is diverge because limit n approaching infinity is 1.
Yay.
16 it's converge or diverge? Converge?
Oh, I got it.
What?
Yeah, I think so. But it's
But
like
it's not.
not converge.
When you take the derivative, -1 is like
It's decreasing. According to graph, it's decreasing. It's decreasing, so it's converge. Okay, also, question 17, a lot of people says they didn't know why to do. Do you know what 17 is?
limit to infinity is divergent.
It's diverge, what else?
Yeah.
It's gonna be like sine of pi. Hold on, 1 is gonna be pi over 2, and then 3 pi over 2. So it's gonna oscillating, so it's not strictly decreasing. Also, yeah, so it's oscillating. So same thing reason for 18. 20 is a converge or diverge? Converge, okay. That's it. Question 22, is that converge or diverge? Diverge? Wait, 22 is the diverge or converge? Diverge, why? Okay, got it. Yeah, it's diverge. All right, so today we want to talk about absolute converge and conditional converge. Okay, so yeah, conditional converge. Okay, so
Very clear. Ratio? What? Organic function?
Oh, yeah.
You're not safe, because guess what? It's water.
Very pure. Well, look at What?
All right. Shh. Okay, so sometimes a series might be alternating, but not entirely. Okay, so situation like this, you have to use a different way to resolve. But I'm gonna give you an example. Sometimes it happens. Okay, so what you're gonna do is, if the series summation of a to the n converge, then the series of an also converge. Okay, so that is just a, this is called absolute convergence. So if you absolute value it, and if it goes converge, then the series also converge. Okay, so I'll give you an example where, why is that kind of important? It looks like kind of alternating, but it's not. So this situation is happened like this situation here, which is n equal to 1, infinity of sine n over n squared. Now let's talk about why they are alternating. Do you know what the sine of 1 is?
Positive.
Are you sure?
Yeah. Yes.
Yes, it's 1. Okay, so 1 is positive, right? Shh. What is the next integer? What is sine of 2? Is that positive?
Yeah.
Yes.
Is sine of 3 positive?
Yes.
Yes.
Is sine of 4 positive?
No.
Do you guys see why or no?
No.
Okay, so
Trig is dumb.
shh. So first of all, the 1, 2, 3, guys, you have to understand 1, 2, 3, they are radians. Radians. Katie, I can talk over you. Okay, shut up, Katie. Jeez. I just really want to say shut up, Katie. It's so much fun to say. Look at her face. All right. Shh. Some people don't know why, but one, for you guys didn't know, 1 is 1 radian. Those of you guys didn't know, 1 radian is roughly 57.3 degrees, which is almost 60 degrees. Now, there's a reason why it's 57.3 degrees, because 2 radian is roughly 114 degrees, right? If I know how to add. 114.6 degrees, and a 3 radian is what? 100 what?
Where the hell did you get that number? Oh, hell no.
171.9. Okay. Shh. So if you sign of all this value, it's positive. Do you see what I'm saying? But if you got 4 radian, then it's gonna be past 180. So it's gonna go to third quadrant. And that's why this is not alternating series, but it does have sign changes. Because about every 3 terms, about average, because 3.14 is the cutoff line. After 3.14, it's going to become negative. After the 6.28, become positive. Does that make sense? So this is not an alternative series. It's not. But you can prove it. You can say, okay, well, according to that absolute convergence. Katie, put your phone away. You're always in trouble. All right. Is it because you're white? And woman? All right. Shh. Racism. Right.
Let's go.
I'm gonna get canceled after this.
No, we support it. It's okay. We support it. Straight white male will support you.
Yeah.
All right. So shh. So what you can do is, since they are kind of alternating, and they are not really alternating, they are alternating every third term, and or on average is every third term. Sometimes gonna be second term, sometimes gonna be third term, depending how they're rounding. So then you say, hey, let's just look at the absolute value of this. So let's do sine of n over n squared and just do absolute value of this. And if you absolute value of it, what you can compare to, which kind of test I want to do here, and compare to like what something we know of. Huh? I think this is too simple to be limit comparison. Just do comparison. Okay. Now, why is that? Because sine of n over n squared, it's much lessly to which one? N squared. There we go. Why? Because sine can be maximum 1. On unit circle, as sine of 90 degrees is 1. So you can do direct comparison test. Direct comparison test is going to tell you, okay, well, this one is going to be converge. So therefore, the series also converge. So this one will lead to converge because this one is a P series. It's converged. So this one will cause this to converge using DCT. Because absolute convergence help me. Why it help me? Because it just makes sure it's absolute value of it. So I only look at the positive. And when it reaches infinity, it doesn't matter anymore. Any other questions? Now, today's main lesson is what's the definition of absolute and conditional convergence. Okay, so yesterday we told you harmonic, alternative harmonic is what? Alternative harmonic is converge or diverge? Converge. So I'm going to go back and change that definition just slightly. In the converge, there is something called absolute convergency, and there is a conditional convergence. So I'm going to write down the difference between two, and it's really, really confusing. Even for me last year, I was kind of confused me for teach it, but this year I get slightly better, hopefully. Absolute and conditional convergence. Okay, so 1. the series summation of a to the n is absolute convergent when summation of a to the n converges. Okay, so far okay? Second one, the word's kind of very similar, so that's why it's confused part. The series of summation of a to the n is conditional convergent. When summation of an converge, but summation of absolute value an diverge. Does everybody understand that?
Harmonic series. Harmonic series.
Very good.
Harmon series.
Harmon series.
Get it? It's like Harmon.
Thank you for that. Thank you. That's so witty.
We are so quirky and unique.
No.
British? What?
Yeah.
So let's look at a harmonic series, alternative harmonic series. And if I just have n equal to 1 and infinite -1 to the n over n. Due to AST, so that's alternating.
Yeah.
Check, right? Is limit n approach infinity of 1 over n is what? 0. Check, right? 1 over n is always decreasing because 1 over n plus 1 is less than 1 over n. Check. Alternative series says this is converge. But what if I have absolute value of this? That's going to be 1 over n, right?
Yes.
Is this series converge or diverge? This is diverge. So therefore, harmonic is no longer just converge. It's converge in a special category. Conditional. Convergent. So harmonic is conditional convergent. Because P series say is diverge. And it fits this more right here because absolute value. Why did I do absolute value? I get rid of the -1. And this is diverge, but this is converged due to AST. Does that make sense? So this will end up to be a conditional convergent. So harmonic is not just convergent, it's actually conditional convergent. Is that correct? Okay. Yep.
Conditionally convergent? Is that like 1 over n is conditionally convergent?
1 over n, yeah, it's conditional conversion.
Like convergent when it's has like an alternating.
Yeah, we start by testing. So according to the first statement says A to the n converge, right? Is A to the n converge due to alternative series tests? This is converge, right? But if I do absolute value, I just treated this absolute, this is equal to absolute value A to the n, right? This end up divergent because it's harmonic. So therefore, this is called conditional convergence. Does that make sense? So I'll give you a different situation. Actually, I won't know. I just I'm gonna find out, but I don't really know the difference, but I just know that there's a conditional converge. So what are you gonna do? Summation of n equal to 1. Okay, so what is this? This, if you had to prove, you had to prove me all the way. You can take it like in the multiple choice, you can figure out right away. But this one, you have to show me what is this. Okay, so I'll show you versus summation n equal to 1. Information here is n squared. So on your test, some questions gonna ask you not only are they converge or diverge, are they conditional converge, or they are absolute converge, or they are divergent. So you got 3 options now. You got a diverge for sure, and you got an absolute and conditional. So absolute conditional only usually happen in the alternative series test, because that's the only time you need to use absolute value to don't exclude a negative to the thing. So the first one is what? Conditional. Why?
Because it passes all the absolute mean.
It passes all the AST. Then if you do absolute value of it, it's a P series less than 1, so it's conditional. Does that make sense? So Asim say it makes sense. How about the rest of you guys? Paige says wait. And what happened with this one? This one's absolute. It's absolute convergent.
Opportunity cost of the second one. No. You know, that's comparative. I don't want to compare back. The second one's going to be more numbers than the first. That's absolute advantage. However, when you
Are we gonna have to find the conditions?
Huh?
Like, we know it's conditional and convergent, do we have to say?
You have to say all the reason like here, what I should say. You have to write down all this, which is alternating. Are they alternating? Yes. Is limit approach n approach infinity is equal to 0? Yes. 1 over n plus 1 is less than 1 over n? Yes. So it's converge here, but you search the absolute value of it, and then you can find out that is actually diverged, then it's gonna be conditional converge. Now, if this part here go into converge as well, so it's gonna be absolute converge. Okay. Any questions so far? Yep. N squared is this problem versus this problem. So one is conditional, one's absolute. There's two problems. There's a 1 and 2. So I'll let you try one here. Summation of n equal to 1 of infinity of -1 to the n over ln of n plus 1. This one's kind of hard.
It's okay. It's better than 8 instead of summation.
So there's a question that you have to use direct comparison. What would you compare with? 1 over n. So if you do DCT, summation of n equal to 0, infinity 1 over n, this is diverge, right? And 1 over n natural log of n plus 1 is it greater or smaller? Smaller than 1 over n. No, it's bigger, right? Bigger, yeah. And this is a diverge. So this is also diverge because DCT. So now this one is diverge, so therefore it's conditional converge. Because alternative series says it's converge, but the absolute says it's diverge, therefore it's a conditional convergent. Okay. All right, so I'm gonna give you two things. I'm gonna give you two things. I'm gonna give you a whole review packet of all the tests. Okay, so tomorrow we're gonna go over the homework and we're gonna talk about the errors. So tomorrow we're gonna talk about the error. The error is what is the small errors between between the alternative series, what is the error exist? Okay. Yeah. So I'm going to do one more illustration. So for example, if you have alternative series, right, 1 over n, -1 to the n, n equal to 1, infinity, and let's just use 10 space for example. So I'm going to go in from here, this is a 5, this is 10, right? So I'm going to go the first one. The first one is n equal to 1. Let's do it equal to n plus 1. So that's going to be equal to 1, right? Plus what? Minus 1/2 plus 1/3 minus what? 1/4 plus 1/5. Now, pay attention to all those things because visually I'm going to show you what happened, why they are converged. So if I'm first, I'm going to assume this is a 0 and this is a 1. So first, we're going to go in from here to here. Visually, this one's 1. And then, so this is S1, right? So now S2 is going to go backward to halfway. So I use a different color. Backward, I'm going to use different color to show you here. That's going to be S2. Does that make sense? And then S3 is plus like 0.33. So it's going to be, I use a different color to show you that. 0.33, so it's roughly right here. So this is S3. And then visually, hopefully it start making sense. S3, let's do 1/4, so it'll be 0.25, so it'll be 2.5. So roughly, it's S4. Do you see what I'm trying to get to? And let's use green. And going from here to here, about 0.2. And the next one's 1/6. So 1/6 is about 0.16. So I'm going to use this 1/6 about here. So this is a S5. This is S6. So, and eventually, that's why it's gonna go to converge to a single value. So this is a visual representation of what happened. I should have shown you this yesterday, right? Okay, sorry. Okay, so does that make sense? That's why it's converged into, if I go to infinite, it's probably gonna be between here. You can find out the margin error, just like you said. It's going to be plus something and minus something. And the things about it, it's always compared to the next term. It's always compared to the next term. The margin of error is going to be less than the following term. I don't know if that makes sense.
I think so.
Less than following term. It doesn't make sense. Okay, so I'm gonna try to explain that part, and I'm gonna do that tomorrow. So today's homework I'm gonna send you, but I'm also gonna put a 12-page review sheet on the things. It's due on Friday, so that's due on Friday. This homework is due today. I'm gonna airdrop to you.
Wait, what?
That's on Friday.
It's
Because it's gonna take me longer to explain the error. I don't wanna confuse people. Okay, so this is what the textbook says to answer RJ's question. I don't know if it makes sense to you. I'm just gonna read it to you. RJ is asking what's the difference between absolute convergent. So they say if the series is absolute convergent, then in term can be rearranged in any order without change the sum of the series. If the series is absolute convergent, then its term can be rearranged in any order without changing the sum of the series. If the series is conditional convergent, then in term can be rearranged to give a different sum. That's what the book says. That's it. And I watched some professor lectures. They didn't say anything, but this is what the book says. I'll take a picture to show you.
I told Sharon she's
Okay, I'm gonna airdrop the homework to you. I airdrop the homework to you. You can start now. Miriam, I'm trying to airdrop to you. Oh.
You can't do everyone. You can only do it for 10 minutes. So it's like I have to pay for everything you find.
Wait, what does that mean?
Like with the new update.
Uh-huh.
If you don't have the first time, but if you want to drop it, like, it only does it for like 10 minutes.
That kind of makes sense because there's like random people airdrop you stuff. I did. It says waiting. Yeah.
But like in terms of waiting, I'll just say this, because think about every like foundational document or
So mean.
no.
Okay, if you turn on airdrop, I can also drop your review packet as well.
No, long no, please.
So this is a review packet coming up.
literally saw it.
Watch that.
So there is two things I can give it to you. One is a picture, one is actually a PDF file. PDF file, it's a review sheet. The picture is today's homework. You can start review sheet early.
Yeah. Wait, what's that?
Start. Enter a phone number. Okay. Your phone number. Okay. Yeah. And then what? I have to do it again? No. But that I didn't put it in.
That's what I was going to say, but then I was going but then I stopped. You know, I didn't hear your mom last. Oh. I'm the Hey. Wait.
And this is why we.
What's the next one?
So the absolute.
Trying to hide it there.
Hi, Jack. Oh,
Hi, Jack. Hi, Jack.
Mafia.
What? Is Paige okay? I want to check the bathroom. She didn't pass out in the bathroom.
No, I said you check that.
Don't worry, I'm your favorite. I'll be back soon enough.
Is she back? You go check the bathroom. Make sure she's okay.
If I don't come back, she's fine.
Okay.
student going to bathroom.
Oh.
She's okay.
Yeah.
Let's give up.
Students, 1 minute remaining until class.
Oh, that's weird.
I feel like if she went to the next, she would have taken her stuff.
You were playing a ball too?
I think her phone is here. Oh, Juju, are you okay? Oh, so you're at the nurse.
I can bring it stuff too.
We're here, but yeah, we can take your stuff if you want. Oh, yeah, they're
Hello?
on now. Are you okay?
Okay. I got her.
Okay, we'll just give it, okay?
I'll bring it to her.
Alright.
Alright, that's.
Okay, well, at least she's at the nurse.
Oh, okay. No, that's, I did that.
Yeah, she did not know. She said she fainted, so like,
She fainted, and why did she faint? It? She go outside. She was
I didn't know.
just say you were helping Jinju.
I'll help them bring stuff over.
Yeah.
Bye. Thank you.